cooking, baby. Okay.
Ellie.
Hi, Ellie. Yeah, everybody can say hi to Ellie.
Hi, Ellie.
Hi, Ellie. So
What?
we're recording this for Ellie since she can't be here. Who knows? Maybe it'll end up on YouTube. So here we go. So let's do this now. We got to take the formula. So far, all we've done is develop a formula for the nth term. This formula works if n is a number like 27 or 100 or 56 or whatever natural number you like. The question is there a way of taking this formula and using it to add up the infinite series, add up all of them? So we have that the s sub nth term, or our formula for s sub n, is a sub 1, 1 minus r to the n over 1 minus r. Okay? The way we're going to add up all of them is we're going to say, we're going to let the limit as n approaches, we're going to take the limit as n approaches infinity of this. Are you still with me? Now, we're going to obviously take the limit on both sides, so I'm going to have to squeeze the limit in over here, so I'll erase this. We're going to take the limit of this side. We have to take the limit of this side. So I'll take the limit as n approaches infinity of a sub 1, 1 minus r to the n over 1 minus r. Now, at first glance, this looks undoable. And by the way, we rewrite this notation just for convenience, s of infinity. And then I don't need this. This means this. Okay? So s of infinity, if I add all the terms, I'm going to take the limit of this side. Now there's only n in one place, and it's up here. The question is, how does this help us? Okay, you say that term goes bye-bye. Now,
If r is less
this is it. But say that like you mean it.
if r is less than 1.
Okay, and we got to be careful. We say r. Let's say the absolute value of r is less than 1, because we don't want to use -5. -5 won't do it. Allie is suggesting that if this is a fraction, if this number is a fraction, either a negative fraction between 0 and -1, or a positive fraction between 0 and 1, this term goes away. Now think about that for a minute. Let's say I have a common ratio. We just had a common ratio of a half, but let's choose a different common ratio. Let's take a common ratio of 1/10. What is the limit as n approaches infinity of 1/10 to the n power? It's 0. If I multiply a fraction by itself an infinite number of times, what happens to the number? It gets smaller and smaller and smaller. What's a half times a half? A fourth times an eighth times a half is an eighth times a half, a 16th. It keeps getting smaller and smaller, and so what happens is I approach 0. So as long as r, the absolute value of r, is less than 1, this term goes away. That just becomes 0. What am I left with? I'm left with a sub 1 over 1 minus r. This is one of the oddities in math where adding up an infinite number of things is easier than adding up just some of them, because the formula simplifies. Do you all understand why r sub n goes to 0? Vicky, do you understand why r sub n goes to 0? Oh, that look means no, not so sure, I can tell. Okay, let's back up for a second. So Vicky, give me a fraction. Any fraction you want. Give me a fraction, anything. Yeah, give me a fraction, something between 0 and 1. 7/10? Okay. So let's have a common ratio of 7/10. Let's actually put it in here. Here's our formula for s of infinity. S of infinity equals the limit as n approaches infinity. Now you said we're going to let our ratio be 7/10. Okay. So I'm going to have 1 minus, or I need my first term, and we'll let our a sub 1 term, let's let our a sub 1 term be 6, because it's a pretty number. So we'll say 6 times 1 minus, now for r here, I have r to the n, so I have 7/10 to the n power. And this is all over 1 minus 7/10, 1 minus r, right? Vicki, what happens when I take 7/10 to the infinity power? Because I'm going to replace n with infinity. What is 7/10 to the infinity? Zero. If I have a fraction, when I multiply two fractions together, what happens? Number gets smaller. 0.7 times 0.7 is 0.49. I multiply by 0.7, it gets smaller. It goes to 0.343. Keeps getting smaller and smaller, right? So as long as I have a fraction here, this term always goes to 0. It is beautiful. So let's go back to our original problem. Our original problem was, can I erase that side of the board for space? Okay. So we'll leave that formula floating around at the bottom. We'll work above it. So the original problem we had was we had a sequence. Our sequence was 1/2, 1/4, 1/8, 1/16, 1/2 to the n. And we said, what happens if we add it all up? And we said intuitively you get 1. Now we have the means to prove it. Our formula says that S of infinity equals A sub 1 over 1 minus R. So what's our A sub first term? 1/2. So in this particular case, I get 1/2 over 1 minus, what's my common ratio? I get a half divided by a half. 1. Very sweet. Okay, let's use the same formula to prove that it works on something else. I said this is the first problem. It wasn't. The very first problem we did was 1/3. You remember that? We said 1/3, and I'm going to erase this because I need this space. We said that 1/3 is 0.3 bar. What's this fancy bar called? Okay, I don't like it being called a repeating bar. That's what we call it in 4th grade. Called a vinculum. This is a good word for hangman. If you ever play hangman, especially my international students, you will always win if you use vinculum. Because no one will have the foggiest idea what you're talking about. So this is the same thing as 3/10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10 to the n plus, so we have an infinite series here. Let's rewrite this. What's my common ratio R? My common ratio R is 1/10. What is my A sub first term? It's 3/10. Okay, so let's plug it into our formula.
So 3/10.
So 3/10 on top.
Over 1 minus 1/10.
1 minus 1/10. 3/10 over 9/10.
Nope. 10 goes 3/9.
3/9. 1/3. Cool indeed. Too fast or good? We're good? Now if you take a look, this is exactly what they do on page 595. Yes? Now, why do I develop this first? Well, if you're going to start talking at the beginning of chapters about repeating fractions, we should put this at the top of the chapter. So I've done this a little bit out of order. We looked at page 1, or page 592, and then we jumped over to 595. Now we need to go back and fill in the details in the middle. By the way, this notation, S of infinity, some books use it. Our book actually just calls it S. So you'll probably see this formula. They just don't use the infinity subscript. They just say a capital S mean for the sum of the infinite series. I prefer writing infinity because it's unambiguous. S can mean anything. So I prefer this, and you'll probably see me write it that way. Yes? Okay. So now we're back on page 593. we have a couple of questions we have to ask ourselves. This particular infinite series, well, let's just look at this one, the very first one. This infinite series, divergent or convergent? It's convergent. We added up an infinite number of things and we got a number. Amazing. Okay? That's convergent because convergent means you settle in on one number. What does divergence mean?
Or it's anything that's not.
It's anytime you don't settle in on a single number, you're divergent. Most of the things we'll be looking at which are not divergent, they tend to go to infinity, but they don't have to. What's an example of something that doesn't go to infinity but is divergent? How about this? What if I take what if I have, what if S sub n, or let's not say S sub n, what if my terms A sub n equal sine of n?
Yeah, because there's no apparent.
Right?
It's not going to go to specific.
Sine of n oscillates infinitely, and so you're all over the map. You never settle in on a single number. What if A sub n equals minus 1 to the n? What does my sequence look like then? Assuming we start with n equals 1, what's our sequence? Negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. What happens if I add those all together? What do you get?
You don't, because it keeps on going.
Well, it depends. If I add an odd number of terms, I get minus 1. If I add an even number of terms, I get 0. Do I converge to a single number? No, you can't even talk about convergence because, well, if you say, well, which is it? Do we end on an odd or an even term? You can't. You have to add up all of the terms. So what is it?
What is all of the terms?
Don't know. So divergence happens whenever we don't settle in on one particular number. So when we did sigma 1/2 to the n power, converging. Sigma 3/10 or 3 over 10 to the n, convergent. Yes? Okay, so the question comes now, those were examples. Notice those were examples of something very important. Now this is where we've got to keep series and sequences straight. This is what I'm about to say for the next 2 minutes is crucially important to understand. So if you were taking a mental break for a minute, dial in.